All right, hey kids, this is a recap on Objective 57. This isn't meant to be the whole lesson or to include every little thing. This is just for those of you who are absent and those who might need a little refresher or help on getting started on your homework. Today we studied how to use function notation. And before getting into that, we did do a little bit of a review on what functional and non-functional relationships are, and this information is from Objective 57. So remember that any pair of numbers, whether they're generated randomly or mathematically, they are said to be in a mathematical relationship. And if you have your notes, you can fill in with me. Now, a relationship can, like I said, be generated by math or random, and it can also be either functional or not functional. And remember, for a relationship to be functional, then every x has to have its own y. And so here are some examples that you can refer to, just kind of a short list in case you've forgotten. When you see that the x is different, so in a coordinate the x comes first, right? When it's different, you don't have to worry about x being with different y's. You just know without even looking at the y's that this is going to be a function. Now, don't freak out if you see that you have the same x and automatically just assume that it's not functional. An x can reappear as long as it's with the same y. So 1 is with 3, and it's okay if I have 1 as an x again as long as it's with 3. And so 1 is with 3. So this is a functional relationship still. And remember that it's okay for y's to have multiple x's. And so working backwards, if y is 3 several times, it doesn't matter if it's with the same x or different ones, it's fine because y can have multiple x's. So if an x has its own y and be functional, it's not functional if x has 2 or more different y's. So here's an example of a not functional relationship. Here I have 1 repeated as an x, and the first time it's with 3, and the second time it's with 10. And that can't be. It can be with 3 or 10, but not both. And so we also had some new vocabulary words, input and output. Input refers to the x value, and output refers to the y. And so today we're going to talk about functional relationships and function notation. And so here we go. So a function is kind of like a processing machine where you put something in to a machine that has a particular job to do and it spits something out. So kind of like a wood chipper, right? You'd put a tree branch in here and it chips all the wood up here and it sticks out wood chips here. Or if you have a machine that mixes bread dough for you. We talked in class about the Casey's pizza bread dough machine, right? You put all the ingredients here and it mixes, and it spits out some dough. And a machine is kind of analogous to that too. So we put something in and the machine does a particular thing to that number and spits something out. So let's say we have a machine that's a mathematical machine, and what it does is it has the job of adding 5 to all of the numbers that go into the machine. So here's the in. Remember, in is the same thing as x, or in is the same thing as input. Let's say we put -1 into this machine, and the machine has the job of adding 5 to all of the x's. So x plus 5. So if I put -1 in, and the job is to add 5, -1 plus 5 is 4. 4 would come out of this machine. Or if I put 0 in, 0 plus 5 is 5 out. Or if I put 1 in, 1 plus 5 is 6 out. So that's an example of a function. And so you can apply this to real life situations because no one's just going to sit around and do, math problems like this for a living. let's say you own a bowling alley and you need to calculate the cost for your customers to pay you for bowling. Let's say this machine is calculating the cost to go bowling for a various number of games. Let's say a game costs $3 and the shoe rental is $2. Now, the thing that varies in this situation is the number of games that people bowl. Maybe some people really like bowling a lot, and maybe some people don't like bowling at all. So because the number of games can vary, that is our variable, or the x. And regardless of how many games you play, all of those games are going to cost $3 a piece. And then in addition to that $3 per game, we need to pay $2 for the shoe rental. So now we have our little function or our little machine that we can use. Now if I want to play one game, I'll put 1 in. 3 times 1 is 3, plus 2 is $5. Let's say I want to play 2 games. Put 2 in, 3 2s is 6, plus 2 is 8. I'm only going to add the 2 once because, you know, once you rent the shoes, you don't need to pay that more than once. And 3 games, put that in. 3 games is $9, plus 2 more for the shoes is $11. And so what's fancy about mathematical functions is you can work backwards too. So let's say you have 20 bucks and you want to just go to the bowling alley and bowl as much as you can. You can work that backwards. Well, if I have $20, take off the $2 for the shoes, that's $18. I have $18 to spend on bowling at $3 a game. Well, I can bowl 6 games. So that's an example of how you can not just go from input to output, but output to input. So oftentimes we use what's called function notation. To calculate these situations. Function notation is always going to start with, it's usually italicized, that means the tilty letters, right? And like this, and you would say that out loud, f of x, or if this was a different letter, it'd be like g of x or h of x or whatever this letter is. And whatever's in the parentheses, the number of parentheses indicates whatever the input is. That's the thing that goes in the machine. Okay, so let's say we have this machine, and what this machine does is it multiplies numbers by 5 and then subtracts 6. 5x minus 6. And let's say now I want to find f of 8, right? So here's our original function, f of x equals 5x minus 6. I want to know what happens if I put 8 into this machine. 8 in, what comes out? Well, to show this mathematically, I would say 5 eighths minus 6. Let's do order of operations. Let's do multiplication first. 5 times 8 is 40. Minus 6 is 34. So I didn't solve this like an equation. That's sometimes confusing because there's an equal sign there. But all I did is I substituted this value in for x and then simplified to get 34. So if I put 8 in, I would get 34 out. And as a final solution, I could say f of x equals 34. This means if 8 is the input for this function or machine, 34 is the output. Now, big arrow, big point here. Students are sometimes, often, even confused by this equal sign. This does not mean that this is an equation to solve, kind of like what I said before. All you're going to do is you're going to substitute the input for the x expression. So I substitute 8 for x here, and then simplify. Okay. So let's do an example like what you will see in your homework. Let's say this is the function that we're working with. This is the machine that we have. This machine multiplies a number by 10 and then adds 20 to it. Let's say I wanted to find f of 2. So instead of 10x, I have 10 2's and 20. 10 2's is 20, and another 20 is 40. So I just found that f of 2 equals 40. That's my final solution. What if I do f of 5? That means 10 fives, and 20. 10 fives is 50, and 20 is 70. So f of 5 is 70. Take a minute and see what you get when you find f of 9 and f of 12. Okay, when you're ready, you can check your work. Did you get f of 9 is 110 and f of 12 is 140? I hope you did. Now we need to make sure that we keep in mind that we use order of operations. Now one thing I want to do better at remembering for you guys is to give you a big view of all of your notes so that you can take a screenshot. I'm going to have to hold it sideways so you can take a screenshot of this one for your reference. And now this one, so you can use it for your reference. Okay, so now you should have something that you can use for your homework. So this is Objective 57 homework. I'm going to do sample questions for you, but I'm going to use the redo side so I don't rob you of opportunities for practice. Each of these functions is just the same as the front, just with different numbers. So this is the function in the first one. This means this function is going to multiply the input by 2 and then subtract 5. So f of 3 would mean 2 3s minus 5. 2 3s is 6. Minus 5. 6 minus 5 is 1. So f of 3 is 1. And so you'd repeat that process over here. F of 8 in this function would mean 2 8s minus 5. And then you'd continue to simplify on. Similarly in this one, f of 4 in this function here would be 1/4 of 4 minus 9. Well, 1/4 of 4 is 1 minus 9. 1 minus 9 is negative 8. So f of 4 is negative 8. And so you'll repeat the process. F of 16 would be 1/4 of 16 minus 9, and so on. And this bottom one, it's really important that you pay careful attention to order of operations. So let's sub in first for our input. So this function squares the input, multiplies it by 3, and then takes that product and adds 2. So this would mean 3 7 squared plus 2. Okay. Order of operations, say to do parentheses first. 7 is already simplified. Now exponents. Our exponent is 2, and it's on the 7. So 7 squared, or 7 times 7, is 49. Plus 2. Next is multiplication. 3 times 49 is 147. And then last, add 2. So 149. F of 7 is 149. Okay. Hopefully that helps you. Okay, and so give you a second. Take a screenshot of that so you don't have to go back and listen 14 times. I have something for notes. And so the front side. You have very similar questions on the front that you can muscle through. If you have any troubles at all, please don't hesitate to send me an email at drones@gmail. Nope, sorry. d231.net. Okay, good luck. See you on Monday.